Welcome to this series of presentations on LXI. This is a summary presentation of networking basics, providing only as much information as is needed to understand the use of LXI devices in a typical LAN environment. Content of this video comes from the LXI Networking Basics document found on the LXI Consortium website. The last slide in this presentation gives you a specific URL to locate this and other LXI learning documents. A network is a group of devices, such as computers, printers, LXI devices, etc., that are interconnected with each other. The LAN configuration shown is actually the recommended configuration for building an LXI-based test system. This presentation will help you understand basic LAN connectivity and how LXI devices operate when connected to a LAN, so you can better understand how such a system operates. Each LXI device usually contains a built-in LAN interface, but that LAN interface could also be a plug-in accessory. This figure shows an LXI device with multiple interfaces, including LAN. The LAN cable connects to the RJ45 connector of one LAN device to other LAN devices through a cable, a hub, a switch, or a router. Notice the locking features of a typical RJ45 LAN connector, which serves to protect against accidental disconnection. The Open Systems Interconnection Model, OSI, helps you think of networking in terms of abstraction layers. Different communication technologies with similar functions group into different logical layers on the OSI model. Each layer of the OSI model makes use of functions provided by the layers below it and provides functions used by the layers above it. The LXI specification focuses on layers 1 through 3. The LAN hub, switch, and router are the primary interconnecting LAN devices. These devices have multiple ports and allow multiple LAN devices to be interconnected. The hub and switch look identical, but they are quite different. The LAN hub is a layer 1 device, which means it is involved with the electrical signals sent over the LAN cable, also a part of layer 1. The hub sends the signals from one LAN port to all its other ports. Every LAN device connected to a hub sees the traffic from every other LAN device. This causes collisions and slows down communications, since every device on a hub must share access to the same signal path. LAN handles collisions using a method referred to as 802.3 CSMA/CD, where each LAN device must detect collisions and withdraw access for a random time before retrying again. Adding more devices to a hub simply increases the chance of collisions on the LAN. The LAN switch operates at the layer 2 level, where it keeps track of which LAN device connects to each port by noting its MAC address during initial communication from the devices. The MAC address is a 12-digit hexadecimal number used to create a unique hardware address for a LAN device. The first half of the address represents the manufacturer or vendor of the device. LAN hubs are rare, but still available and used for monitoring the traffic between devices when debugging or analyzing LAN traffic. A typical layer 2 switch does not allow this capability since it isolates traffic between ports. However, commercial-grade LAN switches do provide a concept called port mirroring to allow a LAN analyzer to monitor the traffic of any port. LAN analyzers can also be a standalone product or software running on a computer using the computer's LAN interface. The LXI Consortium members often use a network protocol analyzer called Wireshark. This configuration was covered in the Connecting with LXI presentation. It is simple. You plug the device into the company's LAN, and the DHCP server gives it an IP address, pretty much like a computer. In this case, your fancy new LXI device is also accessible to every other computer on the network because you use the same LAN switch to extend the LAN ports connected to the company LAN. This illustrates what happens when the connection to the company LAN is actually broken. The computer and LXI device automatically ask for an IP address. However, the DHCP server does not see their request because of the broken connection to the company LAN. Since the LAN devices connect to the LAN switch, there is actually a LAN connection, and they will wait about 2 minutes before taking things into their own hands. At that point, they will begin broadcasting an auto IP address in the range of 169.254.x.x, which is an IPv4 address. If an IP address is already in use, the inquiring LXI device will just pick another IP address until it finds a unique one. If a LAN device has no connection to another LAN device, it will recognize no connection and automatically come up with an IP address of 0.0.0.0 and indicate with a LED or a message on its front panel display that no LAN connection exists, which refers to a LAN status fault in the LXI specification. Note that the same auto IP process occurs if you directly connect one LAN device to another. For example, you could directly connect the computer to the LXI device, and both will settle on some 169.254 address after about 2 minutes. If either LAN device has auto MDIX or a gigabit interface where that is standard, there's no need for a crossover cable to switch between the transmit and receive lines for proper communication. The LAN router gets its IP address from the DHCP server on the company LAN, which in this example is set up to supply IP addresses in the range of 156.140. This happens through the single port called Internet on the router. The computer and LXI device get their IP address from the LAN router, which comes equipped with a built-in DHCP server. IP addresses are typically in the range of 192.168.1.x from the LAN router, and that is configurable directly on the router's configuration page to pick any range of addresses you want. The Ethernet side of the LAN router is where the protected LAN devices exist. They are isolated from the company LAN network because other devices do not know they exist unless the devices on the Ethernet side communicate with them directly. For example, the computer can access the LXI standard website with its web browser, and then the router will package up that request and send it out on the LAN as though the router actually made the request. The response information returns to the router's IP address, which then unpacks the information and delivers it to the computer's IP address on the Ethernet side. Here's an example of a front panel screen from an LXI device showing its connection information, IP address, LAN status, MAC address, host name, etc. The MAC address is the hardware address of a LAN device, and LAN switches keep track of MAC addresses to reduce LAN traffic. For many test system developers, the IP address is the primary means of communication. The IP address comes from a DHCP server or automatically generated by the LAN device itself. That's the auto IP. Or it can be a static number manually configured by the user. The IP address can also be associated with a host name. Host names are human-readable nicknames that correspond to the IP address of a device connected to that network, BK's DMM or Lab 1 Spec Analyzer. Every LXI device is required to have a host name, and when it connects to the LAN, it will connect an IP address associated with that host name. This is also an example of the MDNS discovery protocol showing the host name and service name, as used typically by printers, which is required by the LXI specification. In this case, you can actually identify a particular product on the LAN by its service name, such as My Favorite DMM. For printers, you typically would present a location description. A subnet mask is a number that defines a range of IP addresses used in a network. Subnet mask designates subnetwork segments, or subnets. LAN devices within the same subnet can communicate directly with each other, while systems on different subnets communicate through a router using a gateway IP address. Subnet masks have to be contiguous ones followed by contiguous zeros, as shown in the illustration. In this example, the built-in DHCP server of the router is setting up the subnet mask, and each LXI device will be told what IP address and subnet mask to use if they are configured to automatically acquire an address from the DHCP server. If you added LXI device 3, which had a static IP address outside the range of the subnet mask, you would not have proper communication between the computer and that device, since its IP address is 140, outside the range of 1 to 128. Note here that the LXI specification also includes IPv6 as an optional protocol for devices. That specifies a protocol outside the range of this presentation, however. All LXI devices are required by the LXI standard to provide a configuration page. This allows the device to be custom configured for a particular subnet. The default configuration from the vendor is to request its IP configuration from a DHCP server. But as you can see in the example screen, you can force the device to use a static IP address, selecting the manual mode. Okay, let's describe that original recommended configuration we talked about earlier. Developers who are out on the LAN network, the company LAN, they can log into the test system computer through network interface card number 1. Once in, they have access to all the LXI devices through the second network interface port. There would be no provision supplied to bridge the private subnet of NIC 2 to the company LAN through NIC 1, and hence you have greater security or isolation for all the LXI devices. Typically, the LXI devices would be assigned a static IP address. This makes documenting the test system easier and is especially helpful to operators who may have limited knowledge of networking. Having an IP address available in documentation allows easy connection checking, I should say, by using such things as ping. Well, now you've got some good background on LXI Networking Basics. More detail can be found in other guides listed above on the presentation and found on the LXI Consortium website. Thank you very much for your time.